Tiếp theo.
Yeah. Okay. Ready.
Welcome to our video presentation about the advanced network design. Here, as you can see, we have design for subnets with 3 subnets containing 4 hosts using /29 subnet mask. As you can see, yeah, 4 hosts. And the another one containing 8 hosts, so we're using the /20 a subnet mask, that is the subnet D. So we also named our devices, routers, switches, and by our name, and we depict their IP address for its connections. For example, you can see at the subnet A, we name our PC from FOC1 to FOC4. The name of switch is FOC1 switch. Yeah, so for the end-to-end connectivity, now I'm going to ping each computer to a router to ensure that the connection is established and its host can ping to other subnets. Yep. I've cleared the table here. So I will ping from FOC1 to the router. Yeah, successful. I will ping from FOC1 to FOC8. Yeah, it's successful. All devices are connected. So onto the layer 2 implementation, we specify one subnet is used for VLAN 10 and VLAN 20. Here, as you can see, that two PC are configured in VLAN 10, that is the take 1 and take 2, take 3 and take 4 is configured as VLAN 20. And obviously, they can ping to each other in different VLAN using a router, which is using a layer 3 device. So I will demonstrate it. I will ping from take 1 to take 3 different VLAN. That is the inter VLAN. Which means that we ping from the host in the from the host to different host from different VLAN. That is inter VLAN. So it failed. I will ping again. Take 1 to take 3. It's successful due to the layer 3. So so now for the layer 2 implementation, I'm gonna turn off the router to ensure that the layer 2 transmissions because that is the sub interface GO/222. Okay. Turn it on. I will turn it off. Okay. So I will ping from take 1 to take 2. Yeah, it's successful. I will ping from take 3 to take 4. So all the steps that I have done is intra VLAN, which means that I ping from a host to another host from the same VLAN. So how it works? Because in Swiss that I configure uh, so free so VLAN free. And you can see the VLAN 10 I assigned it to the BC1 to the BC take 1 and take 2. Yeah, here. For take 3 take 3 take 4 I config VLAN 20. Here you can see. So in layer 2 I will try to bring inter VLAN from take 1 to take 3. It failed, right? I will bring again take 1 to take 3. Not one. It still failed. Why? Because it's in the layer 2 we only bring intra VLAN. The switch only forward the frame from the host to the host which have the same VLAN. This is how it works. Yeah, it's my part. Let's moving on to the full part.
So on to level 3 evaluation. So on this level 3, I'm gonna show you explain how IRP works and demonstrate how IRP uh, gonna process how IRP process on the work in Cisco packages. So first of all, what is IRP and how IRP gonna work? So IRP is basically a process when a host gonna send a package to the destination and on a different subnet. So it's not totally a original normal layer 2 transmission. It have to be a layer 3 transmission. So in order to transmit from layer 2 to layer 3 and layer 3 to layer 2, so the router has to obtain the IP address, MAC address of both sides, both host and destination, and IP address of both host and destination. But the thing is the IP address will remain the same. And only the MAC address will be changed during the transmission. So for example, at port number 8, when he's want to send some packets to the number 5, so he gonna send a payload which contain the source MAC and destination MAC. We will not talk about the IP address during this process. So it will send the source MAC and IP source MAC and destination MAC, which is the destination MAC is Fook router and source MAC is Fook number 8. Then when the packets travel to Fook routers, the routers will acknowledge the IP address and MAC address. Now it's gonna change the MAC address from the source MAC is originally from Fook number 8. They're gonna change to Fook routers, and the destination MAC will originally from Fook routers. Now change to the number 5. And how to identify it? It will based on IP address of the host and the destination, and it will call out the destination IP address. Will call out who has this IP, and in that subnet who has the IP address exactly as a router is calling, which is the number 5. It can answer the calling with the acknowledgement messages and the MAC address. So when the router receives the MAC address from the number 5, it will acknowledge it and change the IP address, the MAC address from, as I said, from the source MAC is Fook router and destination MAC is the number 5, and here is the demonstration. So from Fook number 8, it will change to the number 5. And here's a simulation. So first of all, it will travel from Fook to layer 2 devices as a switch. It will travel to routers, and the routers will change the MAC address over here. So when it finds out that is a destination by using my IP address to find the MAC address, then we send to the switch as a level 2. Then from layer 3 to level 2, from layer 2, it will send directly to the, and that is how layer 2 gonna work. And then the process continue as the communication continues. That is how level 2 evaluation work and how ARP work. So move on to the last one is task number 4. It's a web server. Here I have a web server that I have well configured. Here's our services, the HTTP service and the default gateway. So now I'm going to demonstrate how the server works and how the OSI references encapsulate the packages. So first of all, we're gonna type in the IP address of it. So when we type in the IP address, now the process will start at the first packages, the first frame, where the layer 3, layer 7, and layer 7, the HTTP server clients will make a connection to a server. Then on the fourth layer, the TCP. So the device tries to make a TCP connection to the server on port 80, and now the encapsulation process begins. When on layer 7 is the information that we want to transmit. It will encapsulate layer by layer from layer 7, layer 6, 5, and start from layer 4. We're adding 4 headers. Except the window size up to here. Here is adding more segments and headers. And next we will add on layer 2, 4 is encapsulate adding more headers segments. And to layer 3 we're making that instrument through default gateway. And layer 2 adding more encapsulate PDU into in Ethernet frame. Now we transmit into copper file. So on the next frame, from the host the package will travel from layer 2 switches. Now it has been encapsulated as a level 2 packages. Now as you can see, it's on level 2 and level 1. So only switch only care about layer 2, so it doesn't care if it's layer 3 or layer 4. It's only care if it's layer 2, it will transmit. Then it will transmit to layer 3 devices, which is routers. Then it continue to transmit. Then until the server has received the server. Now, as you can see that now the server has received the packages. Now it will encapsulate layer by layer, same as how it's encapsulated. So from the bottom to the top. So from the port internet, so we're gonna encapsulate the PDU from the internet frame. Then it will encapsulate the packages, and it will set connection state to receive and also retrieve the MSS value from maximum segment size into the TCP header, and now all the packages will be decapsulated into human readable and depicts on display out on level 7, which is our web browser, and and they will send a message like a sync receive to acknowledge that the message has been transmitted successfully, and the server to send the message back as the communication continues. And that is all how the ARP kind of works, and now is for the HTTP packages. So the first package is for the ARP, the communication for acknowledging. Then the following behind is the packages, the packages which is HTTP over here. Then the server will encapsulate here, as you can see. From internet, port internet, encapsulate layer by layer 1, 2, 3, 4, and finally the server receive HTTP request. And now the connection will continue to send back as the user continue to make communication with the server. And that is how OSI Lab model references encapsulate and decapsulate the packages. And thank you for listening to our presentation.